Hi students, good morning. Our today's point is also a physical quantity and it is a torque. So write down torque. It is the fourth physical quantity. So write down it as a point 4 torque. It is denoted by this letter tau. It is not T. And the question will be asked on this point is also important question, so denote it as a VVIMP. And the question is, write down this question: derive derive an expression derive an expression for the torque derive an expression for the torque acting on the rotating body acting on the rotating acting on the rotating body. Write down this question. And we know that answer of this question is expressed in 4 points: consideration, diagram, notation and mathematical part. But the simplicity is that these 4 points are quite similar to the previous derivation of the rotational kinetic energy. Only some changes are there. Otherwise, the expression is performed in similar manner. So write down the consideration. In the previous consideration, we consider a rotating body with a uniform angular velocity omega. The difference is only with a instead of uniform velocity, it here uniform acceleration. So our consideration is: consider a rigid body is rotating about an axis of rotation passing through the any point O with a constant angular acceleration alpha. So write down: consider consider a rigid body consider a rigid body is rotating. Write down this consideration. Consider a rigid body is rotating about an axis of rotation passing through consider a rigid body is rotating about an axis of rotation passing through any point O with a constant angular acceleration with a constant angular acceleration. Write down this consideration and prepare your notes while watching this video. Constant angular acceleration alpha. So this is our first point of this answer. Second point, now it is a diagram. We know that in the previous point there is omega and here is alpha. Now we already know that how to draw this diagram. Draw first this cross and add the end points of these lines. Denote M1, M2, M3, M4. Now the distance of M1 is R1, M2 is R2, M3 is R3 and Mn is Rn. Now denote linear velocities V1, V2, V3 and V4. Vn. and then give it boundary, and it shows a body and denote here angular acceleration alpha. Draw this diagram. Now this point is also repeated in the next article. So please notice that these type of derivations are three in this topic. Three derivations are similar: rotational KE, torque and angular momentum. Now third point is notation. Write down let comma or let m1 comma m2 comma m3 comma up to dash dash mn comma and mn, m1 comma m2 comma m3 comma dash dash comma and then mn are masses of particles, and r1 comma r2 comma r3 comma up to dash dash comma and then rn are there distances. Write down this notation. Are there distances from axis of rotation, from axis of rotation respectively, RESPT dot. This is our third point, notation. And the fourth point is the mathematical part, and it is the main part of this answer. Now write down when rigid body, write down this, when rigid body rotates, comma, then each and every particle of the body, each and every particle of the body, each and every particle of the body performs UCM. Underline this. Performs UCM, because the formula in UCM are used in this remaining mathematical part. So UCM is an important word for this mathematical expression. Now we know that force is analogous to the torque, and therefore we are going to express first force, and from the force the expression for the torque can be expressed, and therefore the close relative quantity of the force is acceleration, and therefore from linear acceleration we are going to use angular acceleration, and this relation is already studied in UCM, and therefore here there is a use of UCM. So write down first the linear acceleration. The linear acceleration of first particle is पहिल्या पार्टिकलचं लिनियर ॲक्सलरेशन काय असतं बघा, A1 is equal to R1 into alpha because A is equal to R alpha in UC. In UCM, we know that A is equal to R alpha. Now, from the acceleration, we are going to express the force, and therefore, the force acting, the force acting on the first particle is, therefore, the force acting on the first particle is, we know that F1 is equal to M1 into A1 and is equal to M1 into R1 into alpha because F is equal to mass into acceleration. Because F is equal to mass into acceleration. First point is linear acceleration, then force. Now, from the force we are going to express the torque on the first particle, and therefore write down the torque acting on, therefore the torque acting on first particle is, therefore the torque acting on the first particle is tau 1 is equal to R1 into F1 because tau is equal to R into F, and therefore tau 1 is equal to M1 R1 square into alpha. Now this is the torque acting on the first particle, and therefore similarly, the torque acting on second particle is, similarly the torque acting on the second particle is tau 2 is equal to R2 into F2 is equal to M2 R2 square into alpha, and in this way we can express the torque acting on all the particles, and so this is a torque on the last particle, Rn into Fn, and here it is Mn Rn square into alpha. In this way, from the first particle, the torque is expressed by using three formulae. First is A is equal to R alpha, second is F is equal to mass into acceleration, and third is equal to tau is equal to Rf. Similarly, we express the torque on all particles, and therefore the total torque acting on the body is therefore the total torque acting on the body is, and it is tau is equal to tau 1 plus tau 2 plus up to plus a tau n, and therefore is equal to M1 R1 square alpha plus M2 R2 square alpha plus up to plus Mn Rn square alpha. We know that this term can be compressed by using this M1 R1 square plus M2 R2 square plus up to plus Mn Rn square into alpha, and here we know that this is I, or this is compressed as summation I goes from 1 to n mi ri square into alpha mi ri square into alpha, and therefore our last and main point is tau is equal to I into alpha. This is our required expression. Write down, this is an expression for the torque. This is an expression exp dot for torque. This is an expression for torque.